All right, everybody. Today we're going to be going through lesson 7, which is the draw loop. This is a really important concept for you to understand as we move forward because all of your games and any animations or motion that you have in your program is going to be inside of what's called a draw loop. So you need to make sure that you understand this concept very well. So let's get started here. All right, so this lesson introduces the draw loop, one of the core programming paradigms in Game Lab. The class combines the draw loop with random numbers to manipulate some simple animations with dots and then with sprites. So afterwards, everyone uses what you're going to learn in order to update the sprite scene from the previous lesson. So today you're going to be introduced to new vocabulary words: animation, which is a series of images that create the illusion of motion by being shown rapidly one after the other. Frame is a single image within an animation, and frame rate is the rate at which frames in an animation are shown. And it's typically measured in frames per second. In our new code, it's going to be a function draw, which is going to give you the draw loop, and the world.frame rate for that. And we will continue. Okay. We'll go on here, and you're going to get this video.
Animated movies create the impression that characters are moving smoothly, but if you slow them down enough, you'll realize there are lots of individual images. Each image is just a little bit different from the one before. Speed them back up, and your eyes are tricked into thinking you're watching real-life motion. A very simple example of this effect is a flipbook. The key to animation, whether on paper or the computer, is that part of the drawing is changing over time. An easy way to achieve a change is to use the random number command to generate a new random location, size, or color for the shape we're drawing. Here's a simple program that draws a single rectangle with a random X position and a random Y position. If we run and reset this program over and over again, we can see that it draws the rectangle in a new position each time. But that's like a flipbook with only one page. To create real animations, we need to be able to string these pages of the flipbook together. In Game Lab, we'll do this using the draw function. The draw function is special in Game Lab. The commands inside of the draw function are run line by line from top to bottom. But once the computer reaches the end of the commands inside the draw function, it jumps back to the beginning and repeats the commands over and over again, as long as your program is running. Because the code in the draw function repeats in a loop, we'll just refer to this as the draw loop. Let's move our rectangle inside the draw loop and see what happens. Whoa, so many rectangles! We can see that a rectangle isn't just being drawn once anymore. Game Lab is automatically calling the commands inside of the draw loop many times a second. In this program, that means that a new random X and Y location is generated, and then a rectangle is drawn over and over and over. You can place as many commands as you like inside of the draw function. For example, let's choose a new fill color before drawing each rectangle by placing a fill command inside the draw loop. Instead of always choosing the same color, we'll randomize by replacing the red value with the random number command. So in every frame of the flipbook, the computer is picking a new shade of red and setting that as the fill color. Then it picks a new X and Y value and draws a rectangle with those values. In a typical animated movie or flipbook, you don't continue to see all of the drawings that came earlier in the animation. Instead, you have the illusion of a single shape or character moving over time. You'll discover how to make that happen with the draw loop soon.
All right, moving on. So here on Bubble 3, they give you an example of the draw loop at work. It's asking us to run the code to see how it works, and then discuss with your partner whether this looks like the flipbook you saw in the video, why or why not. Click run, and you see we're getting all kinds of these green dots, these green circles drawn all over the place. Okay. Why doesn't this look like a flip book? Well, it doesn't look like that because you're missing the fact that you're drawing each circle on top of each other. All right. So we need to do something different in here in order to get it so that you draw a circle over here and then it draws it over here and over here without seeing three different circles, for example. Okay. And that takes place by using the background. Okay. And when you put the background inside of the draw loop, you're going to be able to erase what your old picture was, and then you put the new picture on top, and that's what makes it look like it's smooth animation here, moving one character, one picture to the next, just like your flip book. Because in your flip book, when you flip through it, you don't see every single one of your flip pages. You see that particular page. You don't see every single one of them. So let's go through here. So an animation is a series of pictures to create the illusions of smooth movement. Each individual picture is called a frame. You usually need to see at least several frames a second for the movement to look smooth. So here's your draw loop, function draw. Okay, that green draw loop is something you're going to get very used to seeing. And you only have one draw loop in your code at a time. One draw loop in your code at a time. That's it. Okay, so don't put in multiple draw loops. To create animations, you need a way to keep drawing frame after frame, so you don't have to keep clicking reset, run, reset, run, reset, run. You want to do it automatically. Okay, and we do that using the draw function. So it runs a piece of code outside of draw, and then to keep running the code over and over and over again, put it inside of the draw loop. In this case, it's 30 times a second, so it's drawing 30 circles every second. Each time the code inside the draw loop runs, a new page, it's like a new page in a flip book. By making small changes to what's drawn each time, you can use GameLab to create animations. All right, so here's your animation of filling that up. Draw loop with sprites. You can put your sprites in to a draw loop. You can move them, but you create the sprite outside of the loop, and then you draw it inside of the draw loop. Okay, it's important to note that you create your sprite. So you create your var sprite here, create sprite at 100, 200. Okay, and then sprite set your animation as green alien. You create it, set the animation outside of the draw loop. Anything that you aren't changing every single time you draw it, you do outside of the loop. Okay, and then inside of the draw loop, you create your background, and then your sprite.x, and you give it a random number between 200 and 220. So now your sprite is bouncing back and forth here between x of 200 and x of 220, which makes it look like it's going back and forth. And you see that you can't see like 100 or 1,000 different aliens. That's because every time it goes through the draw loop, it redraws the background. So your order of your code really does matter a lot when it comes to this. So keep those things in mind. Moving on. All right, so here we are at bubble 5, okay, using the draw loop. Now it's your turn to do some work with the draw loop. Remember that the code inside the draw loop is run by GameLab over and over and over again. All right, so it's asking us to do this. Add code to this program so that your drawing has orange circles being drawn too. Move on when your program looks like the picture to the right. Okay, so we need to add orange circles in here. So we're going to click on drawing, and we're going to go to our fill color here, and we want to change that to orange, right? So our fill color is orange now, because remember, that's like dipping your paintbrush into paint, okay? So you have to dip it in that color of paint before you draw it. And then we want to draw a new ellipse. So we drag an ellipse over here, and we want that ellipse to be at random numbers, random X and random Y, okay? And we want that to be between 0 and 400. And we want that to be between, for your Y, to be between 0 and 400 as well. And then, let's see if I move this over. And then we want to get rid of the length and width for our circles. So we're going to just click that back arrow there. And we'll go ahead and click run. See how that works. And there you go. You're getting your orange and your green circles being drawn about 30 times every single second. And it looks like the picture over here to the right to me. So I say we can move on. Bring us to bubble 6 now. All right, so number 6, bubble 6 is asking you to predict something. So you're going to look through your code here. And we see that we have no stroke. So that gets rid of the black line around the figure. It draws a blue background. And the fill is yellow now. So we're going to have a blue background. Fill is yellow. And then in the draw loop, the background is red. And ellipse is a random number between 0 and 400. X, and a random number between 0 and 400 is its Y coordinate. So its X is going to be a random number, so it's going to move left and right each time it gets drawn. And the right is going to move up and down because the Y is going to be changing between 0 and 400. So it can show up anywhere on the screen here. And the background is red. The fill color is still yellow. So I'm going to say it's going to draw yellow circles on a red background, but each time it draws it, it's going to be drawn over a new fresh red background. So you're only going to see one yellow circle at a time, but that yellow circle is going to be bouncing around. And that's exactly what's happening. Moving on to bubble 7. So here for bubble 7, sprites in the draw loop. By changing the sprite properties in the draw loop, you can animate your characters. This animation has also been slowed down. At the beginning of the program, the world.framerate block has been used to set the frame rate to 10. Usually the frame rate is 30. So 30 is the standard frame rate in code.org. Okay, you can play around with different frame rates and it will change the way that your program runs as far as how quickly it's drawing those, in this case, sprites or the backgrounds, and how quick it's going through that draw loop. Okay, so we're going to run the code to see how it works here, and we see we have our little green alien bouncing around, moving left and right a little bit here between 200 and 220 for its X coordinate. Remember, X is going across, Y is going up and down. X0 is over on the left side, X400 is over on the right side. Y0 is up at the top, Y400 is down at the bottom. If you have questions about that, you can click the Show Grid button that's down here. Picture over, and there's your grid. Again, 0, 0, which is x0, y0 is up in this corner. 400, 400, where x is 400, y is 400 is down in the bottom right corner. Okay, so try changing the frame rate and running the code again. So let's change it to 100 and see what happens here. So we went to a super fast frame rate. You see that now he is bouncing around super quick. He's not going any further either direction, but he's moving a lot faster. Okay, so that's what the world frame rate does. Bubble 8, we have our sprite properties. So if you think of a sprite as a collection of values that represents an object in the real world, then the properties of a sprite are like variables that hold all of those different values. Some of the most common sprite properties include sprite.x, which is where that sprite is found on the x-axis, which is left and right. Sprite.y, where it's found on the y-axis, which is up and down, right? Where y0 is up at the top, y400 is down at the bottom. Sprite.rotation, which is how much it's twisted. Sprite.scale, which is how big or small it is. And if sprite.scale 1 is full size, 2 is twice as big, sprite.scale of 0.5 is half as big, so it shrinks it down like that. And then sprite.visible is either true or false. Okay, so sprite.visible equals false, or gets false, that makes your sprite not show up on your program when it's run. Okay, or sprite.visible true makes it visible. You do not have to say true unless you had first done sprite.visible false. Okay, because it will automatically draw it. So without the sprite.visible true on there. Okay, so reading and writing properties here, sprite properties like variables are values that sometimes we want to just read and sometimes we want to write to. So when you drag in a sprite property, it will take out a different form depending on whether you're reading its value or writing it. Okay, so sprite.x into here is going to show up as just sprite.x, whereas if you put sprite.x over here, it would be sprite.x gets a value. So it automatically does that for you. Moving on to bubble 9. Updating properties. So here we have sprites have properties that let the computer know where and how to draw them. Two common properties to use are sprite.x and sprite.y. Again, sprite.x is where it is on the x-axis. Sprite.y is where it is on the y-axis, up and down. Okay, which control the location of the sprite. Assigning these properties a new value will move your sprite to a new location on your screen. So the animation already, so they've drawn some code up down here. That animation is already updating one sprite property, or one sprite.x property, to make it look like it's shaking, whereas the other one isn't. So let's run the program and see what's happening. Okay, so you see here your pencil is zooming back and forth, right? It's bouncing around, whereas your paintbrush is just kind of staying still. All right, so we need to edit the code in this program to make the second sprite shake like the first one. Move on when your program looks like the picture to the right. So we have pencil is bouncing back and forth. We need to get the paintbrush to move as well. So let's take a look here. So it creates the variable of pencil. at 100, 200, so X 100, Y 200, so it's right there. And it creates the paintbrush at 300, 200, and it assigns the pencil animation, and assigns the paintbrush animation. So again, remember, we create our variables outside of the draw loop, and then we're going to do the things that we're adjusting inside of the draw loop. So function draw here, and we have our background is just white. So we've got our white background, which keeps getting drawn every single time, which is why you don't see 1,000 pencils over here on top of one another. Okay, because it draws a fresh background and then draws the pencil each time, and that's what makes it look like it's moving. And pencil.x gets a random number between 100 and 110, and brush.x is just at 300. So we need to make the paintbrush move. So we're going to come over here, click on math, and we're going to drag a random number in here. Remember, paintbrush is at 300, right? So we'll start at 300 for a random number between 300 and 100 to 110 is only a 10 difference. So let's make this one be 310. So between 300 and 310. And we'll run that and see what happens. And there you can see now both of our items here, the pencil and the paintbrush, are both moving back and forth, just like we want them to. So now we go to bubble 10. Takes a little while to load. Updating properties. This level is very similar to the last, but this time you add in the draw loop yourself. So we just have to go and add the draw loop like the previous program had. So we're going to add the draw loop to the block, or add the draw loop block to the bottom of this program. So we add the draw loop block to the bottom of the program. Move any blocks that need to be inside the draw loop. So we have our salt.y, that should be inside the background, or inside the draw loop rather. Here's our background. We need to add the background inside of our draw loop. Otherwise, you would see 1,000 salt shakers getting drawn on top of one another. So it would look like it's all just one big blob of salt shakers. And we have to add our draw sprites inside of the draw loop. Again, we create our variable, we set our animation, all of that stuff takes place outside of the draw loop. So it's not in the draw loop. But the background, the salt.y gets a random number between 200 and 220. That has to be in the background, and the draw sprites has to be in the draw loop. So we click run, and there we go. You have your salt shaker bouncing up and down, just like the sample picture here. And that brings us to bubble 11. Bubble 11, updating properties. This level combines some of the skills you've already seen. It's drawing ellipses in the background and also updating sprite properties. This time it's changing the sprite's sprite.rotation property. So the sprite.rotation makes it go back and forth like that. Okay? So do this. This animation already is updating one sprite's rotation property to make it look like it's shaking. So if I run the program, I can see that our green alien is rotating. He's doing that, right? Our pink alien is just staying still, and we see all of our little stars in the background here getting drawn as well, which kind of adds a cool effect to it, but doesn't really change anything with our aliens. So again, we create our sprites. The variable to create sprite for a green alien is done. The animation is set. The pink alien is, the variable is created. The animation is set for it. We move on to setting up drawing, no stroke and to fill white. That's only for our shapes, and that's what's giving us these little sparkly stars that are moving around back there. Our background, black, gets drawn over and over and over again. Our ellipse here, random number, again, 0 to 400, and random numbers 0 to 400 here for random X and a random Y, and 5 by 5 pixels, which gives us these little dots that are bouncing around. So that line of code gives you your random star sparkles going around there. If you wanted more sparkly stars, you could highlight that, Control C to copy, and then Control V, paste it in, and we'll get more stars sparkling. Let's see if that works. Okay, so now you've got even more sparkly stars in the background for that. But that wasn't what we were supposed to be doing. What are we supposed to be doing here? We have our green alien dot rotation gets a random number of -5 to 5. I'm going to do this the lazy way. I'm going to highlight this, Control C, and then Control V will paste the same thing down here, okay? And the only difference between what we had there with the green alien is this is supposed to be what? Pink alien. Rotating -5 to 5. And we reset and run that. And now you see your green alien is moving, your pink alien is moving, just like we're supposed to have up here in our sample. Okay? I hope this makes sense to everybody. Work through these. When you get to bubble 12, that's animating your own scene. So I'm going to have you do that all on your own. You can be creative with that and